to be do hands-on with based on timer. Okay, so today I just bring my logic analyzer. Okay, so what we are going to be do is we have to do the with the help of this timer. Okay, we have to configure the timer. Okay, in STM32 for 11 microcontroller. So we are going to be yesterday we did one project. So that is called as an ADC. Okay, so temperature logger system. So that temperature logger system, which is going to be collecting the analog signal to digital data. That extra data are going to be transmitted to the other microcontroller through UART. So each and every data going to be sent for some delay second. Like so first data after 1 second delay, another data going to be sent. After 1 second delay, another data. So this is the basis that actually the data has been sent properly. So how it is actually happening? So with the help of the timer, we're creating some delay. Okay, so it is actually going to be counted. So the pulse is going to be counted for up to 1 second. It need to be sent to the other data. Okay, so first of all, this data has been set it. So after 1 second, it needs to be sent the second data. So this is the basis need to be transmitting the data. This is what we have been studying. Right. So by the basis, today we have to be configure the uh, timer, especially in microcontroller. Okay, of STM32 F411RE microcontroller. Before going to do this project, I'm just simply open up my data sheet and reference manual of this project. Just give me a moment, it's just lagging. Okay, fine. So I just open up my both my data sheet and reference manuals and all. So this is my data sheet. So in this data sheet, if you can able to see this well, this page number 15. Okay, page number 15. So you can able to see the internal block diagram. Okay, so this is the internal block diagram of your STM32F411RE microcontroller. So what are the peripherals? Yes, all the peripheral has been presented over there. Okay. So here we are having the multiple timers, and which timer we are going to be use it for this project is we are going to be using the timer 11. Okay. So here you can also see this one. We are going to be using the peripheral called as a timer 11. So by using this timer 11, we are going to be creating some delay. Okay, like how the event is going to be generated, because with the help of this timer, so if you are generating one event, okay, you just sending the analog to digital converter data. This is the first data. This based on this timer you're configuring. For example, you just configuring 1 second delay. So the second data gonna be sent for after 1 second. So this is the actual thing which has happened with the help of this timer and all. Okay. So for counting purpose and all, we are going to be used for this timer 11. We are going to be especially used to be deploy this project. Okay, so first of all, what the way we have to be perform this operation. So first of all, we are going to be find the which peripheral we are going to be use. Okay, so first of all, the timer 11 I'm going to be used. Okay, so we have to be find it out. This timer 11 has been connected with which bus? Okay, it has been connected with the ABP2 of bus. ABP2 bus. It is having the 100 megahertz. Okay, it is working in the 100 megahertz of ABP2, as well as you have to be find it out the which GPIO pin it has been connected. Okay, so no worry, Rajmohan. So I saw your message. I will share to my team. So please give your required problem also, because based on that I'm going to be share that message to my team. Okay, just share your problem also on the chatting. Okay, so the thing here we have to be see it on to be users. Okay, so if you want to find it out this, you have to be yes. So why we have to be using the timer 11? It's not exactly. You can use timer 10, timer 9, and anything you can able to use. Okay. So I'm going to be give you the task. Okay. So instead I'm used the timer 11. So you people can use the timer 10 or timer 9. Any timer 10 you can use. You can able to use. So if you are using a timer 11, it has been connected with any of the GPIO. Okay. So all the peripheral has been connected with any of the GPIO pins. You have to configure them, and then you are going to be use it for your application. So here I'm just to find it out which GPIO pin it has been connected. I just simply duplicate this page, and I'm just to go to the pin definition. So these are the steps we are just using for every peripheral. Okay. I'm going to be using a timer 11, right? Here, you have to be find it out for the timer 11 where it is. Can you just find it out where the timer 11 it is? Yes, I found it out, guys. So the timer 11 was here. Yes, Sudhindra. So always your GPIO pin has been your peripheral has been connected with any of your GPIO pins. Okay. So that is the thing. So we have to be find it out here. So this timer 11 is connected with this port B of ninth pin. So here I just find it out. It is port B of ninth pin, right? So I just found it. It is a port B of 9. Okay. After you have been find it out the GPIO port B of 9, you have to be check which bus it is actually going to be connected. You have to be configure your timer 11 as well as you have to configure your GPIO B. Okay. So first of all, you have to be initiate these two steps, and then only it is going to be enabled. Just simply enabling the peripheral by giving a clock with the help of this bus. Okay. So for this one, what I'm going to be do is first of all, I just go to this reference manual and go to this RCC register. Inside this RCC register, you can able to see that AHB1 ENR bus. So in this AHB1 ENR, you can able to see that here your GPIOP is there. You have to be enable this GPIOP. So it has been mentioned to be enabled this pass and all. So you want to be enable this. Okay, I have to enable this as well as I'm going to be enable the ABB2. You have to be check ABB2. So you just go to this position ABB2, find it out. Okay, here it is. And here you have to be enable the timer 11. Okay. So that GPIO B located at the second position. This timer 11 is located at the 18th position. So based on that, you're going to be shift the bit. Like you want to set the bit as 1. So for that, you have to make the left shift up to 2 times. Okay. Here also, you are going to be set the bit as 1 to make this timer going to be enabled. And for that, you have to be shift the bit up to 18 times. Okay. Here it is common. Why yesterday we studied like, so if I want to be enable the timer, because this is just for enabling purpose, you're just telling to a microcontroller, I'm going to be using a GPIO port B. Okay, just simply telling that. But if you just see it on here, that you're just telling the complete timer 11 you're going to be used. Timer 11 going to be performing some action. So I'm going to be use it for some other event. So for that, you have to be enable this timer 11 with the help of this ABP2 bus. Okay. So here I'm just going to be enable this bus and all. First of all, I'm just declare the AHB1ENR bus. Okay. So here I'm just doing this, write the peripheral name. Okay. So why we need to shift up to 18 times means you just see this position, guys. So this is how based on this is how your peripheral has been allocated. Okay, if you're inside your microcontroller. So if you are going to be taking like buses, okay, it has been connected the buses. So all the peripheral has been located at this position. So it has been each and every peripheral has been located at this position. So these are the register. If you are taking a timer as having the different register, status register, control registers and all. Okay. So inside this, you will have to do the specific bits. Okay, so if you want to be enable the timer, especially inside this microcontroller, you have to enable this one. Okay, for that we are just shifting and enabling the one. And if you want to use the inside the registers, peripherals and all, you are going to be set the specific one. Okay, if after that we will move to that work. Okay, so I just enabled this timer 11, which is located at this 18th position. That's fine. And now I'm going to be implemented in this code. First of all, this RCC AHB1ENR. Okay, I just returned the address. Okay, how can I take it? You just go to this debugger mode. You just simply go to the RCC. Okay, so inside this RCC, sorry guys, just okay. So it is enabling here. So I'm going to be use it on here. Okay, so okay, so we will take it all from here. Okay, so if it is disabled, you just go to this Windows and you can also enable this SFRs show in view. So and you can easily enable the SFRs. Okay, so after this, guys, I'm just simply going to be enable the RCC register. So here my RCC register is there. So inside this RCC register, you can able to see that AHB1ENR. So I'm just taking this AHB1ENR as a register. Okay, so I'm just simply taking the HB1ENR as a register. So I'm going to be using it as a macro here. But the thing is, I need the address. Address is very, very important thing. So I'm just declare my, this is the address. Okay, that is how I've been declared it is. And then, so you need to be enabled the ABB2ENR also. So you have to be enabled the ABB2ENR also because you're going to be using the timer also. Right. So you're going to be use the timer 11. For that, that is located at this bus. Okay, you need to be enabled both the address priorly. Okay, and after you can enable the bits and pins. Okay, so in this, while you come to enabling this pins and all, so what you're going to be do, what I told you already. So your microcontroller does having the peripherals like multiple peripherals, each has been connected with this bus and all. So this is the very important first procedure. You have to be enabling your peripheral through this bus. Okay. So here also, if you just see this one, I'm enabling this timer through this bus. I am enabling this GPI open through this bus. With the help of this bus only, it is giving one clock. So with the help of that clock, it is actually enabled. Okay, it just enabled. Okay, then you can start to do your normal procedure. So I've been enabled with the help of my bus. So that's what I just did. So first of all, you have to be write the address and then you just enable the bit. Here you can able to see that I'm just enabling the peripheral. So if you just see this one, here I just returned the register name that is AHB1ENR. So this is the AHB1ENR is the register. For this register, I need to be enable the clock. For that, I've been used. I'm going to be shift the bit for. I'm going to be set the bit of 1. For that, I'm going to be shift up to 1 time. So here you can able to see that here it is actually 1. So why it is 1? Because this I'm going to be show. You have to be see this position, guys. Okay. So see this position, you have to be shift the bit up to 1 time. So it is in this position of 1 also. So it's not starting from 1. So it's starting from 0. So you have to be shift the bit up to 1 time. Okay. So here you have to be consider, I'm going to shift the bit up to 1 time. And this one is have to be shifted up to 18 times. Okay, you have to be shift up to 18 times you are going to be shift. So making this procedures, you just simply enabling the clock and you can easily enable the timer also. Okay, after completed this procedure, so you just deep dive into your peripheral enabling. Like if you just see this when you can able to see the timer level you're 11 you're going to be creating some event. Okay, so what you're going to be doing, you have to be set the which GPIO mode it is actually going to be performed. For that, you are going to be enable the MODA register. Okay, so in this MODA register and all, it is you just go to this MODA. Okay, in this moda register, you have to be using the pin called as in. We have been find out it is a port B of ninth pin, right? So it is connected with this pin of port B of ninth pin. In this port B of ninth pin, you are going to be see the mode R of 9. Okay, in this mode R of 9, what you are going to be set, whether it is input, output, alternative or analog. So we know that the timer going to be performing input capture mode, output capture mode. So kind of multiple function is going to be performed. So for that case, I'm going to be enabling the alternative function, that is 10 in this position of here. Okay, so what I'm going to do, I'm going to be shift the bit. This is the binary value of 2. So I'm going to be shift the bit up to 18 times to set this value of 10. Okay, that's what I did. First of all, you have to be written the address. What is the mode R? B address. So make sure don't confuse it. Each GPIO B address and all having a different value. So this is this address. 400 2040. So this is the address of this one. So I just simply enable that pin. Initially, since it is having a 2-bit mode, first of all, you just reset the bit. Okay, in this reset the bit, you just taking the 2 value. That is a 3. Okay, since it is having a moda, every moda pins having a 2-bit. I'm just taking a 3. The 3 it is having holding high value of 1. So I'm just making it as a not operator. With the help of this not operator, just making 0. So I'm just clearly clear out the bit which is located at this position. Okay, so I'm just clear out the pin which is located at this position, and I'm just shifting the bit up to 18 times. I'm going to be shifting the bit up to 18 times. It's been after that I've just implemented this position like going to be shifted up to 80 times. Here also you can do the 18 also. Okay, I've just glittered the value instead of writing a solid 80. You can split the value called as an. Okay, so that's it. And after that, so whenever you are working on this alternative function, you definitely map the value because it is having the multiple pins and parameters. You have to be map the value. For that mapping the value, you just go to the alternative function mapping. So in this alternative function mapping, AVP port B of 9th pin, port B of 9, timer 11 is located at here. What is the alternative pin? It is AF03. So this pin you are going to be mapped on the position of AFR. Okay, you can also, we have been studied yesterday, whether you are going to be choose AFRL or AFRH. You have to be choose AFRH because your pin GPIO pin B of 9. Okay, GPIO, but no reason, Suresh, no reason. So you can also write 18 because you can see it on here. Here I have written 18. Okay, here also you can write 18. So we can also use like this procedure. Why? Because we have to use this procedure means whenever if you are having the multiple configuration you are going to be doing. Okay, multiple moda register you are going to be using for that case. You just simply use the for loop. For example, I'm just initializing pin. 2 pins I'm going to be using. The 2 pin, you have to be set the same mode or value as this value. That time you just simply configure a pin and I'm going to be inside this loop, we can easily write and it is going to be set to the value, what the value exactly want to be set. So for example, if you want to be set 0, 1. So for 2 times if you want to be set, you just easily given that value. Okay. For example, you just initialize with the initialization with 2. You can easily make that. Okay. So here I'm just doing like I just filtered this value. So while you are going to be doing some other project, you can easily understand. So here I'm just doing AFRH as oh, yes, it is AF03. So you are going to be set to the AF03 at the position of, okay, you have to be AF03 at the position of AFRH. Okay, here it is. Okay, here you can able to see that AFRH 9th pin. Here you are going to be set the position pin of AF3. Okay, so initially you just reset the value. Okay, you just 1111, make it all reset. Okay, how you make it all reset? So just using a NOT operator. I'm using a EF is one of the hexadecimal value of 15, making it as a NOT. I'm just clearing out the values. Okay, all has been cleared. Okay, and after done this one, I'm going to be set the bit as 0 cross 3. Okay, you can write it in hexadecimal also. That's fine, and make it left shift up to 4 times. Okay, and simply set the bit at those position. Okay, and just simply set at the position at all. And after completed this work, so up to we just simply completed the this is the GPU open. With the help of the GPU open, you can configure the timer. Timer going to be work this position. Okay, that's good. And after timer can able to work like it is going to be provide the how it is going to be generating some delays. So how you can able to understand those concepts by studying the complete timer. Okay, so here you are going having the multiple timers like timer 2 to 5, timer 9 to 7, 11 and all. Here I'm going to be using a timer 11, right? So in this timer 11, 9, 10, 11 and all. So it is a 16-bit auto reloader counter value. So here, what are the stuff you have to be understand is what is timer? It is going to be used for the various applications. Okay, you can able to generating the delays, counting the events. So for that, you can easily do this. The timer is that like. Okay, in this parameter, what are the what are the things you have to be understand? How the configuration is going to be happen. If you are having one timer, you will have the multiple registers inside the time. You will have the multiple registers inside the time. For example, if you are taking a timer, so you're taking some clock. From example, if you can also take it clock from any crystal oscillator or any input bus clock. So okay, it is taking some clock. Okay, it is taking clock. Okay, to providing some delays. For example, it is taking a AHB1 okay, it is not exactly taking that bus. For example, it is connected with ABP2 bus, right? So in this ABP2 bus, it is having 100 megahertz. It is in the 100 megahertz frequency. So when you are going to be use it for your event, for example, same yesterday example, we will take it like ADC. So ADC data you are going to be sent it to the other microcontroller for every 1 second you are going to be send it. Okay, instead of common delay, you are going to be using a timer going to be generate this delay. Okay, so for every 1 second, it is going to be send the data 1, data 2, data 3, how we have been sent it yesterday. So for this scenario case, you have to be analyzed this timer going to be generate this delay. So what are the things you have to be understand? So it is going to be taking, for example, clock from this bus or internal clock is also there. So 16 megahertz. Okay. For example, it's just taking a 16 megahertz clock source, it's just taking a timer. So you cannot directly use it for your application or even. Because, for example, you only want the 1 second delay. You just only want the 1 second delay. If you're using it directly for 16 megahertz, what is the formula of timer and frequency? Both are inversely proportional. Timer is inversely time is inversely proportional to frequency. Frequency is inversely proportional to time. Both are inversely. The formula also comes like frequency is equals to 1 by time. So time is equals to 1 by frequency. Okay. So if you want to be find out the time, you just having the frequency value that is 16 megahertz, you will get the what that is the time value. Okay. If you just calculate the value, just go to this calculator. So 1 by 16, 1, 2, 3, 1, 2, 3. So this is the time. So in time, we are going to be calculated 1, 2, 3, 4, 5, 6, 7, 8. So this 0 is going to be answer, right? So it's about 6.2 nanoseconds, so 62 point nanoseconds. So based on the power, you're going to be considered the nanosecond value. Okay, so this is the time basis we are going to be calculated. Okay, this is fine, but I didn't require the nanosecond values and I need 1 second. Okay, I need the exact value of 1 second. What to do? Okay, for example, you need a 1 millisecond. What to do? Okay, so for to be get the exact value you want to you need the time value. You have to be reduce your frequency. You want to you have to be reduce your frequency. Okay, if I want to reduce the frequency, what can I do? What can I do? So I can able because both are inversely proportional. Since it is having a 16 megahertz, what you got? It is having a 16 megahertz. It is a high frequency value. You just got the value called as only 62.5 nanosecond or 6.25 nanosecond. It is less. Time is very nanosecond value. I don't want this nanosecond. That's what I'm going to be reduce the frequency value, going to increase the frequency value. Like I'm going to be get the value in seconds, the frequency is going to be definitely reduced. Got it, guys? Yes, Prakash. Yes, Prashant. Yeah, exactly. He answered. Yes. Yes, with the help of the pre-scale, Sudindra, exactly. Your answer is also right. With the help of the pre-scalar value, you can able to reduce the frequency. So while you are going to be reduce the frequency, that time the time is automatically get increased. Okay, so this frequency, this formula we are going to be implemented here. So based on what timer you required. For here, I'm just required the uh, 16 megahertz. I'm just using from the internal clock. I'm going to be reduced. I'm going to be reduced with the help of the pre-scalar value. How much you want to be reduced? You have to be tell it on the pre-scalar value. Yeah, I'm just reduced for up to 16,000. If I'm going to be reduced the 16,000, half of the value is going to be reduced. I will get only the value called 1,000. Okay, so I'm just doing what the value I will get it for 1,000 and just easily do the calculator. So what is 1 divided by 1,000? So based on that, I will get 0. I will get millisecond value. Okay, so it is for 1 millisecond. Okay, so yeah, so I've got 1 millisecond value. After that, okay, after that, here you are going to be implemented in your program first. First of all, you have to be read it from the scratch. So what they are actually telling, it is a 16-bit auto reloader. So yesterday, ADC is also 16-bit, timer is also 16-bit. So what is auto reloader value is? Here I forget to tell you guys. So this is pre-scalar. Pre-scalar means how much you want to be reduced, how much you want to be reduced. That value you are going to be upload. For example, here if you want to be reduced for 16,000, you are going to be upload 16,000. Auto reloader value means the reduced final value. Here I just reduced by the value. It is finally I got 1,000. That is the 1,000 is your value. Okay, 1,000 is your value. That value are going to be loaded. Okay, so auto reloaded value means once you have been loaded this 1,000, it is automatically count from 0 to 1,000. Sorry, 0 to 999. Okay, once it is going to be reaches this 999, it is going to be created one event. Okay, so after it start to be count from 0 to 999. So it is going to be trained like you have to be count up to 999. Once you have been reached, started from 0. That is auto reloader value. Okay, so you're having a 16-bit auto reloader value. You can also use it for the various pulse width modulations also. We can able to do output capture modes, input capture mode, everything you can able to do. And then you're going to be study the features. What is the feature of this one? So tomorrow we will detailedly study about the complete what is PWMs and what is timer, and we will study that concept. Okay, so after this, we are going to be we will discuss about the how the timer 11 main features are actually going to be performing. Okay, so it is auto reloader value. So this is also the feature. What are the functionality it is actually going to be? That's what we configured the alternative function. We are able to see the input capture, output capture, PWM generation, one pulse mode output. So these are all it is actually doing. Okay, so for that we are just doing this one. So first, you have to be study the complete time-based units, and you have to be get the data. And before that, yeah, each and everything. So if you want to be configure the input or output or whatever the mode it is having separate procedure. Okay, it is having a separate procedure for input capture mode. What you are going to be doing for output capture mode? What you are going we are not going to be using a PWM, so we are going to be using a output mode. Okay, here we are having a output compare mode. So for to be generating some results. So in this one, so this function is going to be control the output waveform indicating when a period of time has been elapsed. So this is what we are going to be doing. Okay, here we are not generating any new event. I'm going to show you that how it is actually working. Okay, we can going to be visibly see that one. Okay, so here was first of all, it's just telling like assign the corresponding output pin to the programmable defined output. Okay, I'm just duplicate this one. Here I'm just open up this timer. Okay, so initially what they have been said, it is a 16-bit auto reloader value, and you have been study the features, concepts, and okay. Here also they have been given how it is actually performing the block diagrams. Okay, so I've been open. I'm just compare those things, and I'm going to be tell you each and everything. First of all, this is for timer 9 to 11, same procedure. So if you're using a timer 9 to 11, the same procedure. So what this actually telling, main block timer, it is having 16-bit counter. So the counter clock can be divided by the prescaler. We are going to be using a prescaler value to be just to divide the value. The counter can be auto reload by the prescaler register, written by read or write by the auto reloader. So once this is for reduce the value. Okay, the prescaler going to be reduce the clock value. The auto reloader value going to be like a automatically going to be it is going to be uploaded. It automatically can once it is reaches that value, it is going to be generating the new events. Okay, so for that time base, you have to be use the counter register. For prescaler register, you're going to be use this register. For auto reload register, you have to use this one. Okay, also you can study this what they actually try to do. Auto reloader register is a preloader. So this is actually going to be do the content of the preloader register transfer to the shadow register permanently, or each event going to be uploaded. So you're going to be enable the UEV. So depending on the auto reloader register, which is you have to be enabled this register. Okay, and which is presented at the CR1 of register. Okay, so the update event is going to be sent by the UDS yes 1 bit with which is presented at the CR1 register. And also the generation of the event is going to be configured. So whenever the new event update is going to be updated, so for that you're going to be generate the new it is going to be tell you like once the first event has been acquired, it is going to be waited for 1 second after second event. So it is going to be update the new. The counter clock is clocked by the pre-scalar bar. Okay, so by enabling this CKCNT enabled when the counter clock is actually going to be enabled, which is in this bit. Okay, so and slave mode is going to be. So what you are going to be understand hearing. So now the counter clock counting from one clock frequency by enabling. So this is while you're going to be studying this passage. So what they have been given, so you have to be enabling the CEN bit of which is presented at the CR1 register. It helps to start to counting one clock cycle. Okay, that is your very first parameter. You have to be disable it. Okay, why you are instead of enabling, you have been disabling this one? Because previously if any event has been occurred, we are just currently stop this. Okay, we just currently stop this. So why this has been occurred like this? First of all, you just go to this CR1, you have to be enable this CE1, right? So CR, you have to be go to this CR1. In this the CE is presented. So when I'm going to be enable the CE1, the counter has been started. What is counter? So it is clock is going to be get count how many bits. It is actually going to be counting the clock. So based on that, Okay, based on that, so it is actually going to be next event is going to be generated. Okay, before we are going to be starting the count, we just temporarily disable this. Okay, so we just temporarily disable. That means there is no count is going to be happen. Okay, we just stop the initially we just stop. So we have been use the zeroth position going to be reset the value. So zeroth position has get reset. And if you just see this one, so at last only we just enable this counter clock. Okay, why it is has been done this procedure or not? Because when the counter is going to be started, because it is actually going to be taking some clock. Okay, for example, it might be taking a 16 megahertz or it might be taking 100 megahertz, whatever it would be. Not exactly you are going to use this value. Right. Not exactly you're going to be use this value. You are going to be divide the value with the help of the prescaler. Okay. And you're going to be upload this value into this auto reloader value. After that only you're going to be start the counter, because based on that value, if you want 1,000, only you have to be count 0 to 999. Other values I don't want it. So after did this divider auto reloader values enabling the peripherals or all only, you start the counter. You can also see it here, right? So after did this procedure, after you just stop and start the configuration only, it is going to be stuck. Okay, so that's what we have been enabled. First of all, disable and then going to be enabled. So after this, you are going to be counter register going to be do this work. And if you just see this one, the auto reloader registers preloader by writing this one. You have to be enable this ARPE, which is located at the CR1. It is actually going to be enabling the auto reloader enable. Okay, so likewise, you have to be enabled for the pre-scalar value, which is in the CNT. Okay, you have to be enabled both of them. Okay, so you have to be enabled the you can able to see in the CR1 you can have this ARPE, that is auto reloader value going to be enabled. So you have to be give one to be enabled. So that's what here we have been enabled this ARP1. So for to be enabled this. Okay, so this ARR value has been just given the value. Okay, you have to be use this to be enabling, because I'm just enabling the auto reload value. You have to be enabled. So before that, they have been given this timer ARR. This is different. This is different. Okay. So in this timer ARR, okay, it is different specific register. Okay, you can also see it on here. Okay, in this ARR register, they didn't give any value. Okay, they are just given the bit only. It is up to the 15-bit bit. So you can able to give what the value you want to be set. Okay, first of all, you have to be set the pre-scalar value. Okay, for that you are having another register. Pre-scalar value, you are having another register called as a PSC. So it is also having this. Here they have been clearly given that this CKCND is equals to frequency of pre-scalar, which is divided by pre-scalar value, which you wanted. So that is the final value. Previously, while you're going to be read this one, what they have been given, this you are going to be output, you will get the CKCND, which is enabled only when the counter bit is enabled, which is on the CR1. So when I'm going to be enable the CE1 bit, okay, I already show you that, because that is the initiating the counter. Okay, counter has started to be count the value, which is located at the CKCNT. Okay, so the value you have to be enabled through the prescalar value. If you just study here, the prescalar value has been getted. It is finally assigned on the CKCNT is equals to frequency value, prescalar of frequency value. For example, I'm taking 16 megahertz divided by the prescalar value which you want to be used. For example, 16,000. Okay, I just want you want 1,000. You will get the 1,000 is your value. Okay, so always the prescalar value are going to be started from like what can I say? So you are going to be started from 0. It is going to be 0 to 999. Okay, so here that's what I've been used for like the prescalar value, you have to be mentioned in the -1 value. Okay. So here also, instead of it is directly 16,000, here you just +1 they have been added. So for that, you just minus the value like 15,009 rupees. Because you are not exactly that. Since the formula is mentioned as prescalar +1, you can't directly give the 16,000. Instead, you just give the 15,009 rupees. It is automatically the one is going to be added. The final formula will be like 16,000 megahertz divided by 15,999 plus 1. It is considered as in 16,000. So what the value are going to be assigned? Please color is still 15,999 only. Okay, this pre-scalar value is final 15,999 only. Okay, you can also see it here. We are going to be using a 1 millisecond of delay. Okay, here we are going to be using a 1 millisecond of. Okay, so the kilohertz of 1 kilohertz. So after that, it is going to be auto reloader value, which is 999. Okay, auto reloader value, which is 999. And this and all that we have been actually taken. You have to be read the output mode. Okay, so why it is having the multiple sections? Okay, so here we are going to be specifically using for the output section. So they have been given prescalar, enable, count, and the counter registers and UEB. So these are all you have to be in. So we are going to be specifically select the output. Okay, so in this output mode, they have been given some steps to be do. Okay, here they have been given the procedure. First of all, select the counter clock. It might be the external, internal, and the prescalar value. So I've been set the clock. Okay, so clock has been internal clock. I'm going to be using 16 megahertz. I've been set at the prescalar value also. It is a 15,999. Okay, that's cool. And then you have to be write the desired auto reloader value. Yes, that's also have been completed. That is a 999. Okay, I've been done the procedure and CCR register. And CCR register also you are going to be enabled. Okay, so that is what we have been enabled to the CCR1 register. Okay, so that is the next procedure we are going to be do. Okay, and we have to be enable that register. And after you are going to be doing this one CCIE build, if you want the interrupt. Okay, in meanwhile, sometimes we can use the timer is going to be act as an interrupt. So that case you can configure this bit. If you are not using that, now we are going to be using any timers and all. I'm not going to be using this. So finally, you have to be select the output mode. All you're going to be implemented on your code. You just go to this one. So for first of all, OCM. Okay. So you're going to be find out which bit it is actually. CCR. So it is having you have to be enabled the CCR bit, and we have been enabled this bit. So what the value want to be toggle. So based on that, you can give it. Okay. Because since they have been given any bit to be enabled, so you have to be set the specific value. Okay. So I'm going to be set the bit of CC. So they have been mentioned it as so go to the procedure. So put this one is and this one is output. Okay. So here we did all the desired work, set it, and we are not going to be using interrupt. Okay. Here you have to be using OC of EM bit and E bit, E bit, and E bit. Okay, which is in CCR. Okay. It is CCER bit. Okay, we are not using the CCER bit. Want to be check it for each and every bit. Yes, this is the one. So here you have to be find it out which bit. So here in the CCRM1, which is having this OC, 1P, PF and M bits and all the things which is present in this register. Okay. So here they have been given the procedure, so don't need to be worried about that. Just simply write the address. Okay, this is first of all just simply write the address of CCMR1 address, register address, and here we are going to use this and all. So based on that, first of all, OCM bit you're going to be enabled. And if you're using a preloader register, you're going to be enabled this. And if you're thinking active high polarity wanted, you have to be used this one. And finally, enabling the output. And the final step is you have to be enable the counter by setting the C bit going to be enabled in this CR1 register. So we did all this procedure, okay, by based on this. So you just go to this each and every register address. First of all, write the address, and then you're going to be clear and set the bit for each and everything they have been given by the step by step. And finally, you have did this well. Set to the auto reloader register one. Previously, I told you have been enabled because you have been using here. That's full. That's fine. They have been set to the value. If you want to be enable this auto reloader register value, I told you ARPE bit going to be enabled. Okay, that bit is presented at the register of CR1 register. I hope you remember that. Okay, so I hope you remember that. So which is here. I show you, right? So I told you that ARPE register going to be enabled. This is what it is auto reloader but is enabled. So it is continuously going to be happening that even again and again. Okay, so that is also going to be enabled. And finally, you just set to the clock. Okay, so after you just procedure has been done, inside this main function, you just simply call this timer 11 as going to be initialized, and here this is continuously going to be happen. That means the timer going to be runs continuously. Okay, so the port P9 is going to be generated for every 0.5 milliseconds. Okay, so now I'm just go to the I already made the connection. Here I'm going to be using a ADK, guys. So this ADK, which is having a oscilloscope, logic analyzers, and every like this is good for the debugging purpose and all. So I'm just using this one. Simply I'm connected, and after that I'm going to be connect my microcontroller also. Just debug this code. Yeah, Prashant. So I'm going to be explaining. So first I will complete this one. Okay. I'm going to be showing you this. So it's debugging here. So there is no okay, it's go for this debugging mode. And meanwhile, we will do this procedure. Here I'm just using like a Scopy. So this is a module like ADK, which is manufactured by our company. So it is developed by our company. So here I'm just open this when how it is actually directing means I need to connect this EADK in my laptop. It is B type port. Okay. So how I made the connection is only two connections only, guys. Here you can able to see it is the pinouts in the bottom they have been given. So you can connect to the pins and all. One pin have been connected port B of 9 because timer we are going to be configured with that GPIO pin. Another one grounded. Okay. Just simply connect it. This is how it is actually going to be looks like. I've been connected in my microcontroller, which is going to be creating some blocks. Okay. So we just waiting for some time. It just need to be connect. Okay, it's got connected. Okay, so after you just got connected, I'm just doing like select one data one channel. Okay, it is going to be called as one channel. So here I'm going to be select what clock pulse you're going to be, whether it start from when it low or high, you're going to be selected, and what mode you're going to be doing. Whenever I'm just using some other protocol debugging, whether the data is properly sending or not. So that purpose, you just selecting your protocols, and if you are just to see, you can do all those stuff. Okay, and here I'm going to be measuring my time. So this is I'm just collecting it as a data, and here I'm just select. I already done here. Okay, here I'm going to be select this. I'm timing configuration up and all. I'm going to be checking. I'm going to be put 10 second. The time base I'm just putting 10 second and converting into the streams. Okay, I'm going to be keep it as in 1 kilohertz. So 1 kilohertz, it is going to be considered for some other day. Yeah. So after I just completed this one, I'm just simply run this code here, and you have to be check it out whether it is right, and you have to be run it on here also. Can able to see the pulses, which is so you can able to see. I'm going to be change the. So it's just telling like it is a 999, so milliseconds. So so it is going to be calculate. Yeah, yeah, yeah. Give me a minute. So you can able to see that. So for every, we have been loaded the value for every 0 to 999 value going to be set it. Okay, closed. Selected to streams and 1 kilohertz I'm going to be set. So you can able to see the capture the timing values. Okay. So for it just providing at every it's consider it as a 1 millisecond or 0. So it is considering the form of 1 millisecond. So in this code it is 0.5 seconds. So here it is like what we can say. So it is considering it is in the form of milliseconds. So I'm going to be try to change for some other value. So I'm considering the seconds. So what it is actually mean is, so at every uh like 1 millisecond, okay, or nine, it just considering in 998. So at every, for example, this millisecond, it is going to be generated one events. Okay, so it's just counting the pulse. So for every this one, so it is going to be generated the pulse. So totally we are going to be have the multiple 0.5 seconds. So the one event is gonna be happen. Okay, it is one complete pulses. Okay, this is how it is actually going to be created one pulse. So it is for each and every pulses is gonna be happen. So that is not one event. So for one event, so it is going to be completed for this. So one event it is going to be provided some sorry. So after this pulses, it is going to be provided some one event. Okay, so it is going to be calculated the values and all. So you can able to check it on here. Okay. So got clear, guys? You got clear? You can able to see that the first event has been generated. 854, and other events has been everything has been considered as in milliseconds. Okay, so yes, that's it, guys.